Okay, it's time for a Blackworm update and the latest experiment after the big reset. I'll leave the original video link so you can see exactly what happened and why we had to reset it. So in this experiment, we're doing the same thing as the last experiment, feeding the same foods. The only difference is I've incorporated the Estes Stones to help the worms anchor before the mold actually builds up. We have 3 different size stones we're using. These are the Cherokee Purple stones, and each system still has the marine pure gem in them. And this is the restarted experiment. And if you notice, they all look great. All the worms are anchored in the stones, just like I assume they would. And they all look extremely healthy. All the worms that I used in this experiment came from the culture that I had to reset. I pulled out all the worms. I got rid of the nitrates in the system and I reintroduced the worms after about 3 or 4 days of introducing the microbial loop back into the substrate. That's where these worms came from. This system is using the Mexican beach pebbles. They're the smallest out of all of them. And all of these stones from Estes were actually soaked in the biofloc bucket before putting into the system. Since the last experiment didn't even make it to the first feeding, I figured it needed all the microbial loop we could possibly give it. And putting the stones into that biofloc bucket allowed for biofilm to form on the stones as well. And if this is the first video you're catching and you're not exactly sure what biofloc is, check out the last few videos that I've put out because it's an amazing concept that is used in larger scale aquaculture, not really known in the aquarium hobby at all. The reason why the worms are picking at that marine pure gem is because it has that biofloc on it from soaking in the bucket. It sticks to any surface it possibly can. That's was the whole point of putting the stones in the bucket to get as much microbes into these cultures as possible. Now, the last culture I threw together is not Estes stones. It's actually the fluval ammonia reducing resin, the stuff that comes either in bags or loose. I wanted to see if incorporating ammonia reducing resin right into the culture would help reduce the nitrates in the system. We saw really heavy nitrates, and if we could stop nitrates from forming, which is cutting off the ammonia production, we might be able to stop the nitrates from rising. And of course, the marine pure gem is helping with that process and also becoming a little home for the blackworms to anchor themselves in. It's also the blackworms' own little dinner table to eat off of. The fluval ammonia removing resin, it's about the same size as the Mexican beach pebbles, maybe slightly larger pieces. The only difference is that the resin is much more jagged than the Mexican beach pebbles. They're very smooth pebbles. So will that play a difference in how easy they are to remove? I'm not sure, but we're going to find out. That's one of the things we're looking for, the ease of removing them from the culture. So all the parameters look great in this. We're going to keep an eye on it. You'll get your weekly updates on what's going on. And I was able to put all my notes again in my little notebook app. And hopefully this video can explain what happened and why we had to restart and why it's looking good now. So enjoy, and much more Blackworm information on its way.
Welcome to this explainer. Today, we're diving into a really fascinating, honestly kind of high-stakes aquaculture experiment, the 1-gram Blackworm stone structure trial. This is a story about how physical structure impacts biological growth. But as you'll see, it's also a massive lesson in how quickly things can go completely off the rails if your biology isn't perfectly balanced. Here's our roadmap for today. First, the structure trial itself, then establishing the baseline, breaking down the 4 unique test systems, checking out the maintenance and feeding schedule, and finally, measuring the final biomass. Section 1. The Blackworm Structure Trial. So what's the big question here? We want to know exactly what happens to worm colonization instability when we introduce physical structure into their habitat. This experiment, which officially kicked off on June 22nd, is a direct continuation of our original food trial. The main goal? Figuring out if adding structure actually increases usable surface area, improves the worm's anchoring behavior, and ultimately boosts that overall biomass. Now, check out how we're isolating our variables. We're using fluval breeding boxes, but here's the kicker. We're adding just a simple 1-inch layer of structure right around the perimeter. We're fundamentally changing the physical geography of the habitat while trying to keep every other detail exactly the same. Okay, Section 2, establishing the baseline. To make this a true experiment, we need strict constants. Every system gets the exact same starting worm mass, 1 gram of aged leaf litter, aged rainwater remineralized to 101 to 120 TDS, and a single marine pure gem. But let's talk about that 5 milliliters of mulm for a second. This trial is actually a restart. The very first attempt totally failed because an immature microbial loop caused the worms to go completely frantic in just 5 days. We literally had to save the whole trial by inoculating all the stones and marine pure gems with mature biofloc. It just goes to show you, physical structure means absolutely nothing without a rock-solid, mature biological foundation. We're also locking in stability across the board with our filtration and conditioning. Every single setup uses marine pure biofilter gems to keep that biological filtration incredibly consistent. And for water conditioning, we're meticulously dosing Chlorum X at exactly 1 teaspoon per 5 gallons of our aged rainwater. Moving on to Section 3, the 4 test systems. Now this is where it gets really fun. All the bags we bought probably say Stony River Premium Aquarium Gravel, but man, the actual stones inside are vastly different for each system. For System 1, we went with the largest, most jagged stones of the bunch, the Cherokee Purple Gravel. We specifically paired this rough, highly textured environment with Hikari sinking carnivore pellets. Will those jagged edges give the worms a much better grip? We're going to find out. Then we have System 2, which is a complete 180. We moved to the absolute smallest, smooth, dark gray stones, the Mexican beach pebbles. It's a completely different tactile vibe, and we matched this one specifically with the Bug Bites Siglet formula. System 3 is kind of our Goldilocks setup. It sits right in the middle with medium-sized, smooth tan stones called jumbo gems. We carefully paired this middle ground physical structure with the Bug Bites tropical formula. And finally, System 4. We actually ditched natural stone entirely for this one. That 1-inch perimeter structure is built from Fluval ammonia-reducing resin, paired up with Bug Bites bottom feeder formula. It's an awesome way to test if a highly porous, artificial chemical media acts differently as a physical anchor compared to just regular natural gravel. All right, Section 4, maintenance and feeding schedule. Since that 1-inch structure is our only true variable, the maintenance routine has to be absolutely relentless. We're talking exact twice-weekly water changes for every system, plus exactly 2 milliliters of mulch and a 1/4 teaspoon of finished compost are added weekly, right alongside some very rigorous water parameter testing. Here's the feeding roadmap for the whole 4 to 6 week trial. Week 1 is a slow start, just 1 pellet morning and night. Week 2 ramps up a bit, and Week 3 hits the absolute peak with 2 pellets twice a day. Now, Week 3 is critical because we do a propagation. Notice the mandatory feeding reduction right after that. We drop the feeding down for 4 days before settling back into a 1-in-1 routine. You absolutely have to do this to prevent fouling the water. Because we are absolutely not disturbing these cultures, meaning knowing the worms every week, we have to rely heavily on visual observations to track everything in real time. We're meticulously watching their feeding response, the exact time it takes to consume the pellets, how they cluster and anchor around those different stone structures, and of course, their regeneration rates following that Week 3 propagation. Which brings us to Section 5, measuring final biomass. So, when we finally wrap this trial up, usually capping at about 4 weeks for efficient regeneration, how do we find the winner? Well, the worms will be meticulously separated from all that stone substrate and the mulch. This independent weighing step is totally non-negotiable. It's the only way to guarantee we aren't accidentally weighing debris, giving us a perfectly accurate final biomass. That single number is the ultimate judge of which setup performed the best. At the end of the day, this entire explainer really boils down to one essential point. To quote the research directly, it's all about parameters and stones providing biofilm surface area. Does a jagged stone grow better biofilm than a smooth pebble? Does chemical media actually outperform natural gravel? Well, the final biomass will tell the story. Thanks so much for joining me today, and I hope this leaves you thinking about just how much of an impact simple physical structures have on biological growth. Well,
This is such an exciting time for people that are curious about blackworms. The days of guessing and assuming are completely over. You have the correct tools and the proper knowledge for successful culture.